We are going to solve a couple of quadratic inequalities. So quadratic inequalities, and we're just going to do that graphically. So the first one I'm going to solve here is right here, the x squared minus x minus 12 greater than 0. So what I do is I simply graph that part of the equation as a y equals, and then I find where the points on the graph that are their output is greater than 0 or greater than the y equals 0 line, and we're left with just greater than. So look at this graph. I think I can see that that point and that point is -3, 0, and that point is 4, 0. So the part of the graph that is where the outputs are greater than 0 is all values of x that are here for all inputs greater than 4, and here all inputs less than -3. So I can write that out in interval notation. Is down here, I'll just say not including 4 all the way up to positive infinity, and here not including -3 all the way back to negative infinity. So that's the solution. All right, one more. Another equation is 2x squared plus 3x is less than or equal to 20. So that's the problem I am solving. All right, in order to graph it, I'm going to go ahead and get everything to one side of the equation so I can have a y equals. So 2x squared plus 3x minus 20 is less than or equal to 0. So now I'm looking for the values where the output is below the y equals 0 line, and it can also be equal to. So I've graphed the solution. I now see my numbers, or my x-intercepts are 2.50 or 5 halves 0 if you choose, and -4, 0. So those are the two. And then the question is, where are the outputs less than 0 or below the y equals 0? And remember that y equals 0 is that line right there. Right, so it looks like all the points are on this curve, so it looks like it's one continuous. So I believe I can say a couple ways of saying this. Interval notation, it can be inclusive, 5/2 here, all the way back to a -4, inclusive also. Or I can say in using the greater than and less than, I can say x has to be less than or equal to 5 halves and greater than or equal to -4. So either one of those is good.